That makes sense.
So I was thinking on doing, so we could do this one, which is the denial of service
Start
stack.
for, oh, for overflow good.
Yeah, have you done this one?
No, I haven't done this one yet.
All right, so we could do this one. There are here, there's just one X, and we can also do, and then this one has all the explanation and everything. I already did that, did this one in the past, but
Okay.
I think it would be good to do it. And
Okay.
then we can also do, there is one from, let me remember which one I did before. So I have a Windows 7 here
Okay.
that a virtual machine where I've tested this before.
Mm-hmm.
Let me just double check. All right, so uh, okay, so there's was some testing that I was doing here. Let me just go back to, oh crap. Yeah, I have the buffer overflow here. Oh yeah, so there's another one that we can play with, which
Mm-hmm.
is the WAR-FTP server.
Okay.
And the save end 31, I think this is another FTP service that we can play with.
Okay.
Let me just, uh, oh. So you have a Windows 7 machine or Windows? Oh, you said that you have a Windows 10.
Yeah, I'm running a Windows 10 machine.
Okay. So let's do the DOS tag good. This one first.
Okay.
All right. So
But
let's see.
which one is that? Is that the one from the GitHub webpage?
Yeah,
Oh, so this actually has a walkthrough as well?
yeah, it has a walkthrough.
Okay.
So I don't want to go through the whole walkthrough. I just want to see,
Just get an
remember
idea of what needs to happen. So,
what's the port that needs to be open
okay.
for it. I don't think it's here.
Well, Jesus,
Uh-huh.
look, why don't we try and make it a little more realistic where we like just don't know the port and we just nmap the host to find out what the ports are instead?
Okay. All right. So I'm just gonna restart this machine one sec.
Okay.
Let me just double check that I'm in bridge mode, or I wonder if it's in NAT mode, if my other virtual machine is gonna be in the same network.
Okay. You said
Okay.
this one is the. Can you paste the link for the buffer overflow? This one, the one that we're using.
Yeah.
Thanks.
So let me get rid of one sec. I have this machine that I have, the virtual one. It's not working.
Okay.
Uh, all right. So I have it running
Okay.
my end.
Okay. Give me 1 second. I'm just getting everything loaded here.
Okay. Go for it.
Excuse me. Oh, did you find out the port that it was on?
Yeah.
Okay. All right, fine. Let me download this sample.
All right. So I kind of get how this was.
All right, give me a few more minutes. I'm almost there.
Okay. I'm just starting to write
Oh, okay, gotcha.
the
Steps.
the steps. So I'm gonna open my pen test guides now.
It's just I'm gonna paste something in the chat now. This is like a little checklist. I don't know if it's gonna be helpful, but you can take a look at that and see.
Yeah, real quick. Yep, looks good.
All right.
I'm gonna paste that in my notes.
No problem.
Okay, so let's start by sending a shit ton of
Yep.
So for that,
Basically, our goal is to just crash the application.
yes, and then so what we have to do is I'm copying here a fuzzer that I got from my OSCP. So let's do here target equal to was IP. So actually, I want to do this. right, so basically the only thing I need to send here is, what's that? No. All right. So do you get it to run already?
Yeah, I'm running it now, so I'm just trying to scan the host so I can find out what port it's on.
Yeah. So all I need to send is hey Chris, we cannot hear you, man.
Asus?
Mm-hmm.
Okay, never mind. I see. Never mind. I see you're working on it.
What?
No. I pasted a script that I was using as a template that you can just modify to send the A's.
Oh yeah. Let me see it.
You just have to delete the shell code and just modify the buffer part just to have the A's that you want to send.
Okay.
Do you guys hear me now?
Yep.
Yeah, we can hear you now.
Sorry, I used my phone to call into the audio part.
No worries. So Chris, you can still hear us, right?
Yep.
So as of right now, we're working on the link do stack overflow good. I'm not sure if you've already done that one before.
No, I just kind of was reading it over.
Okay, awesome. So basically, we just have some Windows
Do we have to
machines
build
set up
like
where,
I was gonna say, do we have to build like a image to put the vulnerable application on, or?
if you have like a Windows VM running, you can just install it on there.
Okay.
Do you have any type of Windows VM?
I do on my desktop. Let me, hold on one second.
31237. What port is this again? Is it 33? Let me check again. Unable to connect the target.
31, 30, 37.
3137.
Yeah. All right, so
31337.
so string in buffer, buffer A, counter 100, then buffer in A dot counter, counter is 100. Right. Okay. Okay, so string right. Okay.
Socket.
Like object is required not string. Why? Like. Oh. All right, I got to exploit the buffer overflow.
Oh, you got it?
Yeah, I mean, well, to just make it crash, right? So
Yeah.
this is my script so far,
Mhm.
right?
Mhm.
So I wanted to make it, you know, to use arguments just
Mhm.
to in the future just use it for something else.
Mhm.
I type here, I can use IP on port,
Mhm.
and then basically it will create a buffer where it will go gradually incrementing the A's or the size of the buffer.
Yeah, by 100 until it crashes the application.
Exactly. And then basically just sends the string, wait for a response, and quit.
Okay.
Actually, quit doesn't even it's not even, well, yeah, I think it's necessary to close the connection.
Yeah.
And then it crashed with 300. So I'm gonna make it increments of 10 this time
Okay.
to see how it you know, to be more specific. So let's try it again. Let's see. Here it's running on, make it run. All right, so it seems like 210 bytes. It crashes.
Sorry, one second. I'm just trying to figure out my syntax.
No problem. So I'm gonna make another input here.
I think I got it to work finally.
Did it work?
it just goes fuzzing with 1 byte and it just stops there. It's not incrementing for some reason, and it's not crashing.
So you have to. So the reason why is because when you connect, you see when you connect to the port, it doesn't do anything. So you have to basically start by sending something. Like if you don't, like you're not getting anything back, right? Unless you say hi, and that's when you get something, right? So
Okay.
let me make it run because it wasn't fun. But basically, connect there, hi, and I get a response. You see? But if I don't send anything, you know,
It doesn't
it
respond.
doesn't respond. So in your code, you gotta make sure that the first thing that you are doing is sending a string, not trying to receive something because you get.
Oh, okay, okay. And that string value, what did you add? You just put a random string?
Well, the string, it's basically a buffer of A's. So what this code is doing, it's basically generating like different buffer sizes. So it's gonna first create a buffer with just an A plus the value with 1 byte, right? That's the first buffer, and then it's gonna keep incrementing this by the value that you specify in the counter. So let me copy this code here so you can have it too.
All right. Thanks.
So I'm checking this here 1 sec. It says argument 3. I'm still adding something here in case you want to add it too.
All right.
So let me see. Yeah.
So it crashes after 300 bytes?
Yeah, but the increment by default, I set it to
100?
by default, the increment it's gonna be 100. So basically, it sends just 1A, and then it sends 100 A's, and then it will send 100 A. So if you want to be specific of how many A's you want to, if you want to see exactly when, you have to modify the increment value. So what I'm doing now is saying, okay, I want you to start from, go from 1 by 1, right? So my increment is going to be, I can tell it to go one by one. The problem with the 1, I think, it's going to be that, A plus by 1 is always going to be 1. So it has to be something.
Yeah, something more than that.
Yeah, it has to be 2. So it's going to go from 2 to 2. Let me try it again with 2. Yeah, and then it's weird because it said that, oh, I see. The problem is that it multiplies and then it adds 200. So this thing right here is just a multiplier. And then this is this is how much it adds. Right. Yeah, so I got something wrong in my code. 1 sec. Okay, counter equal is 200. Okay. So this will be increment. And then got it. Yeah. So all I have to do was update the increment value here to make it accurate.
Okay.
So now it's gonna do, so the first value is gonna be A by the increment, the counter, which is gonna be oh, so it's kind of like exponential. So, yeah. So if it's 100, then 100 A's stars, and then we'll save counter equal counter plus 100. All right, got it. Yeah, I think it's. I'll copy you the
New code. So what exactly did you change?
Yeah, so what I changed was the value that was here. It was 200, the set value. So
Okay.
I changed it by the variable increment.
Mm-hmm.
Also, well, here you need to see the variable increment also. Let me just copy you the same code again, just in case.
No problem.
Right, so the idea of this is that we have some code that we can use again with other exploits.
Okay.
With other, let me try it. Okay, yeah, this is much more precise, it seems.
Okay, got it.
Client.
And the original script that you use, it was a template that they give in the OSCP?
Yeah, yeah.
Okay.
And then here, this is the other important value that you need to change. The length of the buffer, I'm gonna make it like 1,000 because I wanna make sure that it goes all the way to the max value, you see, because right now it ran the 30 interactions and it didn't crash because it's just going from in 2, 2, and 2.
Yeah, it's not enough to crash it so far.
Yeah, so I'm going this way. Let's see. Yeah, so it actually crashes exactly at 145 bytes. It already crashes. I'm gonna try it again with just one increment to see what happens. Yep, 144, it crashes.
Wait, is it 145 or 144?
144 bytes, it crashes.
Okay, okay.
So I guess this is what's good about, being granular, is that you can get to see exactly, which value, but you can definitely just go after, after you know exactly. I mean, because normally there are, normally you want to start with probably like 100, right? But when you do it with 100, then you won't have that granularity of telling, okay, it crashed, with this exact value, because only tells you, after 200, it crashes, right? And then you can go with something more granular and say, well, now I want to try, in steps of 10 bytes, right? And see how it crashes with 10 bytes. So you see how it gets to 150 and so on.
That makes sense.
All right, so I'm gonna use 150 as the buffer to make it
the buffer
crash.
size, you set it to 150?
Yeah, I'm just gonna keep it at 150. And so once you have the initial code, which was the fuzzer, right? And then I'm gonna copy the fuzzer, and I'm gonna make now the exploit, the pi. And then the exploit, it's gonna be similar, but instead of having to create a buffer that's, dynamic, I'm just gonna say, well, the buffer is gonna be 150, right?
Well, first we need to find out exactly where the application crashes, right? Do we know for a fact that it's 150 specifically, the exact number?
Yeah, I mean, well, it crashes exactly with 144, but you can use a little bit bigger than that. You can go bigger. You know what I'm saying?
Yeah.
That's not going to be a problem. What's important is that you are already crashing it.
Oh, okay, I got you now.
So, okay.
Hey guys, I'm in strict observation mode because I'm having issues with my Windows 7 VM talking to the internet.
No problem.
Okay. All right, so let me know if you got it to crash as I did.
Okay, I'm just writing it. I'm just changing some stuff now. 1 second.
Okay, I'll wait.
Windows. I'm still getting errors in my code here. 1 second.
Which error are you getting?
Oh, I think I've used the wrong port. Hold on 1 second.
31337, it's the port.
No, still the same thing. Oh yeah, I got it to work now finally.
Okay.
So for me, it's crashing at 146 bytes.
Yeah, it will depend on the increments that you're using.
Okay.
So which increment are you using?
I used 1.
And it says 146.
Yep, it crashed at 146 bytes.
Are you using the same code that I have or using something different?
No, the exact same thing that you put in. The only thing that I changed was the number. There was the buffer size to 150.
Okay. All right. I don't know. I think that's weird. Let's see. I'm gonna try it again with 1 on it. 145 bytes.
That's weird. Can I take a look at the code one more time?
Yep.
Okay, I see why. The length of your buffer is 1,000. Mine is 150.
The what?
The length of the buffer. I don't see the line number, but do you see where it says buffer equals? Yeah, right there. You set the buffer, the length of the buffer to 1,000.
Okay.
Let me see if that makes a difference here.
Oh yeah, of course. Well, so basically what this does is that it will keep trying until the total size of the buffer it's 1,000. But you
Okay.
can increment this however you want. You can make it. I would even try make it bigger, like probably 10,000 because it will crash anyways. You see what I'm saying? So you don't want it to stop until it crashes. So this number can be super big. It doesn't matter.
Okay. Yeah, this is weird. Now it's crashing at 141 bytes.
Yeah, that's what's happened with mine. It's crashing at 1.
You have to find the exact single byte, correct?
Yeah.
Yeah.
So is there any different? Do you see any difference in the code right now?
I'm looking right now. Buffer equals.
Wait. This is not this one.
Buffer equals a, counter equals increment, while length of buffer is equal to 1,000. I copied the exact same thing. The only thing I changed was the buffer length. And the usage, I'm using that correctly. The port is 31337. That's weird. Everything looks the same, but it's still not giving me.
Let me see if I tried a few times, and you're using an increment of 1 or 2.
1.
Okay. So I'm trying again, increment of 1. Yep, 145. So it seems like it varies.
Yeah, for some reason it's not. Yeah, it's giving me inconsistent results. It's not the same thing.
Yeah. So you see, right now I'll try it again. 142. You see?
Mm-hmm.
So it seems like it's not always the same number.
Mm-hmm.
Around that number, it fails. So most likely it's because it's modifying, like, when after 140 something, it's modifying the EIP, and then, maybe sometimes it gets to an area where it's still capable of going. It's not you don't have a segmentation fault because of the address in the memory, and that's why it gets to a little bit more, like 44, 40, 43, and then that's pretty much like a range, right? So if we were seeing at the pointer here, most likely we're just affecting part of the pointer. You know what I'm saying?
Okay, that makes sense.
So we're not affecting the full pointer by in this number. So that's what I think it would be wise to use like 150 bytes, because in theory you can go beyond that. You can go even like 200 bytes. It doesn't matter, as long as you're crashing the system. It's fine.
Okay, that makes sense.
Right. So then I'm gonna be using 150 in my exploit. So what I did is I copy it to the exploit code, and then I remove what wasn't needed, and I'm saying here that I'm gonna use 150. Actually, I'm gonna just give you this code so you can have exactly what I'm using too. You can modify the name and stuff because it's different.
Nice.
So I'm gonna type here. I'm gonna say this is the exploit, and then all right. So this one, it's basically just one time. If you run it, it should just make it crash with one try. So basically, where is it? Here, just type exploit. Oh no, I think I did something wrong here. Yeah. Have to remove the for string in buffer. You have to remove this also. And then here should be just instead of sending this, should be exploit, and then the length of the buffer. Because this time we're not fussing, right? We're not changing the size.
Yeah.
So that's what makes this one different. Oh crap. Right. So this is how my code looks like. I'm just taking this BoF variable, and if it's not specified in the arguments, it's gonna be 150, and then that will multiply my buffer like 8 by the number of buffer, and then that's gonna be sent to the application. And here I'm just gonna run it again. And it gave me an error. Oh, because the variable string doesn't exist. Now it's called buffer. And only concatenate strings. Okay, so it's because buffer, it's not a node. It's right, buffer equals buff. I'm gonna call this my buffer. I'll give you this code in a second. But all right, so there it should fail as soon as I run it once. You see?
Yeah.
Right. So I run it again. Boom. Just one try. Okay. So that's the exploit's working. So now we just need to work on, making sure that the exploit has the rest of the stuff that we want. So what would be the next step?
So now we got to use immunity debugger, attach it to the application, and find out where exactly in memory it's failing and where the A's are overriding the actual memory.
Exactly. So let's go and open immunity debugger and let's attach to this program. Let's type run. See if it's my computer is slow. All right. So I'm running it here. I'm gonna exploit it. And then access violation, blah, blah, blah. Listening for back connection, check connection, remove host connection, handle off to handle file, I receive, send fail. Oh. All right, so ESP, AAAA, and let's go back, see the notes. Says, all right. Experience, I don't like how this looks.
So did you run it already, Jesus?
Yeah, so I run it, I got it to fail.
So the reason why I'm asking is because if I remember correctly, the actual EIP, do you see it in the upper right-hand corner? The EIP should be overwritten with A's, no?
Yeah.
So something is wrong where the application is crashing, but we're still not getting the EIP to be overwritten with A's.
Yep. All right, so I'm gonna close it and run it again 1 sec, and then we can play with the buffer size. Keep incrementing it till we see.
Yeah, so that overwrites the EIP.
Yeah, so let's detach and it's gonna run it. My computer is a little slow. All right, so I'm gonna run it. Wait. All right. So this is running. I'm gonna exploit it. All right. So what I get, it's access violation when executing this. Shift F7. So I think it's not readable. All right, so I'm gonna try a bigger buffer.
Okay.
I'm gonna try 200 as the buffer size. I got the same error.
I'm just looking through my notes not to see, because I'm pretty sure that EIP is supposed to be overwritten. But let me double check and make sure.
Yeah, no, it is supposed to be overwritten.
Yeah. That's what I'm seeing now. So there's something missing in the amount of bytes that we're sending, I guess. But that EIP is supposed to be overwritten.
So what I'm noticing is that the ESP is getting all A's.
Mm-hmm.
But not the ESP, not the EIP.
A simple restart fixed my problem, by the way. So I'm going to download I'm basically going to try to download the vulnerable application and try to just catch up as we go.
All right, we're not too far up ahead either way. I mean, we're just trying to get the EIP to get overwritten with the A's.
Mm. Okay, so. So were you able to modify the AIP, man?
Not yet. I'm still testing now. I'm just changing up the code a little bit because I think I broke something, but I'm just testing something now.
Okay. So I'm just trying different buffer sizes and see if there's any difference.
Okay.
So based on the notes on about how to exploit this, we're doing it right.
Mhm.
And it's still, what we should be able to see now, it's the EIP gets modified, the EIP.
Yeah. But
But
for some reason, it's not modifying the EIP.
yeah, but I think I'm thinking it might be related with some other security mechanism or something.
Mm-hmm.
I don't know.
I'm testing a few things out now too to see.
What version of Windows are you guys running this the vulnerable application on?
I'm running it on Windows 10.
I'm running it on Windows
Okay,
7.
Oh, I was gonna say it could be an issue on Windows 10 because I know Windows 10 has oh god, I forget the acronym, but Windows 10 actively blocks like buffer overflow exploits like as they happen.
Oh, okay, okay.
But Jesus, you're running it on Windows 7 in yours, so I don't know. I just got it working. Not the exploit. I just finally got up, like the Windows 7 lab. I had to download a DLL because it's old. Let me try launching immunity.
Okay, I got it to work finally.
How?
Are you good?
Yeah, so I was able to overwrite the EIP with ACE. So, Jesus, that original script that you sent, the first one, I'll just paste it back in because you pasted a lot of stuff. I'll just send it back in there. 1 second. Okay, so the one that I just pasted in there, that was the first one that you sent. So use that one as is and just add the arguments, the IP address on the port, and then test it. If you check the EIP, it should have overridden the EIP with 4 A's.
So basically to use the fuzzer.
Yeah, the fuzzer. Like just ignore everything else, all the increments, just send the bytes as is.
All right, let me restart this. For some reason, my virtual machine is also running very slow. All right, then let's do mini. Attach this one. Oh, no. I don't want this so fucking slow. All right, it's working.
You have to hit the play button on the actual. Did you hit play already?
Yeah.
Okay.
It's just very slow.
Oh, okay, okay, gotcha.
I don't know why it's so slow, but
Okay, there you go. Looks like you got it now.
yep.
So you see how this time it actually overwrites the EIP with the 4 A's?
Yeah.
I don't think it's really vital that we know the exact location because we're going to use pattern create. I think it's one of the Metasploit modules to find out the exact location and memory that this is being that the EIP is that this is being overwritten to.
Mm-hmm.
So I think as long as we have like a rough estimate, we should be able to find out the exact location. I think.
Yeah, that's true. But I mean, in theory, what we were doing with the other one should work. It's really weird that it didn't work before. You know what I'm saying? Because I mean, why is it not working? If we are saying, so basically what's happening here is we're sending data, right? And then we're incrementing it until we crashed it, right? So why, when we send like just one packet with a lot of bytes, why isn't that not crashing it the same way?
I'm not. Yeah, that's a good question. I'm not 100% sure because I was having the same issue. Yeah, go ahead.
No, I was saying I've never used Immunity Debugger before. Do I open the running file, or do I attach to it?
So you have to open both the file and Immunity Debugger. It does. The order doesn't matter as long as both of them are running at the same time. And then from there you go to File and then Attach, and then you select the actual application. It should be
I see it. The PID. Yep.
Yeah, and then from there you're gonna have to hit the play button so it can actually start monitoring the application.
Okay, thanks.
No problem.
All right, there we go.
So Jesus. One thing that
play
I
or
did
run?
notice, it's the play button. Run and play. I think it's the same thing.
Okay.
Jesus, so if you go back into Immunity Debug, the actual application, you see how it says the last one, it says send failed at 10038. The one right before it, where it does it successfully, does it say, I'm trying to see if maybe we can get an idea of the bytes from here.
Got it. Well, it says bytes received, so bytes received 102. And then it seems like
okay, 102.
And then the next one is byte received 200, because that's basically what happened. We received one. We send 1 byte. We send 100 bytes, and then we send 200 bytes. That's basically what we sent. And then when we send 200 bytes, it failed.
Okay, that makes sense. Got it. Increment 100. What if I set this to 50?
So in theory, if we send 200 bytes, we're sending 200 A's, stream my buffer plus RN. Let's try to do something here. This is our first send of just test.
So where in the script does it modify the EIP to 414141?
Not yet. We are not in the script. We are not modifying the. So, do you mean in this script? What we are doing is basically just sending a bunch of A's, but nothing else, right? So what we're doing here is taking a buffer of a size of whatever we specify, right? We're going to multiply that by A, so we're just generating all A's. Then we connect, right, to the host here. So we create a socket, we connect. So what I'm just adding here is a first interaction where I do a first test, I send it over, wait for the response, and then I send my attacking buffer, right, which is basically the whatever I specify, and then I wait for a response. So I shouldn't get any response anyway. So I'm just gonna try it again with 200 bytes. See if it works. Double checking that this is running. The thing that what's weird is that we tried it first with the fuzzer, which is basically incrementing the buffer size in a like 100, and it works, right? It modifies the AIP, but when we try with just one big chunk of data, it doesn't work. So that's why we are kind of like trying to understand why is it not working. So just gonna run this. And then I'll try to execute it. You see? It's crazy, but it says access violation, executing blah, blah, blah. But it's not modifying. So the only other thing that's weird to me is the way how this is handling the error. Like, it seems like Immunity Debugger, it's kind of like stopping before the error actually happens. You know what I'm saying?
Yeah, that's how Immunity Debugger works. It's supposed to stop right before the application crashes.
Wow.
Is that what you were asking?
Yeah, but I don't know. Somehow, like.
So as far as I know, the way Immunity Debugger works is it'll especially for these buffer overflows, is it'll monitor the actual crash up until the point right before it crashes. But that's basically just to allow you to be able to see what's happening and what's being overwritten at that time. But if you continue running it even after that, then the application completely crashes.
Yeah, but the problem, it seems like it's not even allowing me to keep running it. You know what I'm saying?
Yeah. Which one?
Yeah. So I wanna keep forward, right? Like keep running, and then it only says, don't know how to continue because memory at address blah blah is not readable. Try to change EIP or pass exception to program. So that's what I think it's happening. Like, how do I pass exception to program?
Okay.
So it says type chief F7, F8, or F9. Chief F9. Chief F9. What's chief F9? It's really weird. It's really, really weird. In the code. Well, that's gonna be like any that's gonna be in my head for a while. Like, why is it not working?
Yeah, the reason why one is working and the other isn't.
Yeah, it's really weird. All right, so let's assume that that's a reality, because I mean let's think about it. The fusser, what is the fusser doing? Sending increments of 100. Sensor connection, string, quit, close. Okay. What can it be? Explore. So I'm just testing with creating a connection, disconnecting, and then sending the buffer in the second connection.
Okay.
I don't know if it's gonna make make a difference, but that's the only thing that the fuzzer is doing. Like, it's sending increments. So before I do that, I'm gonna test it. Okay, it's working. Oh. Nope, nope, nope. Same thing. All right, let's try it again with a faster. So the A's are getting here, but it's just follow and dump. There's only one thing that's weird here. I don't know if you notice. Oh. I think we are not sending the data correctly.
Mm-hmm.
I think we're sending like this.
Mm-hmm.
You know what I'm saying?
Yeah.
So there's something wrong with the script, and it's not sending the buffer correctly. So maybe it's because I'm sending. Right, yeah, I think there's a problem with the encoding. So let me try it again without making this a string, because I think that's the problem. Because you notice this? You notice how it says like A, comma, and all that?
Yeah, and if you look at the one that's actually working, it's just straight A's. It's just a
Yeah,
chunk of data.
yeah, because it's sending like A separated by commas.
Yeah, which isn't gonna, I guess, which technically doesn't crash it. I mean, it will, but I guess it doesn't overwrite the EIP like how we intended it to.
Yeah, and it here. Oh, I see. Yes. Why was this like this? So it has to be like this. Like,
Yeah, and yeah, so basically you're taking A times the actual buffer, not just A and then that by
yeah,
itself times the amount. Yeah, that makes sense.
yeah. So
What
before
happens
I
when you
was,
send that?
yeah, before I was sending like actual, like, yeah, I was sending basically a list of A's
Yeah, instead of sending a chunk of A, yeah.
of A's, exactly.
So when you send that, does it work?
We're gonna test it now, but I think it's gonna work. Yeah, I think that was a problem because we were modifying the AIP. It's just that we were modifying it with other ASCII characters that were not the right characters.
Mhm.
I'm just gonna close this, and then this is so slow. I don't know why. Okay. Damn. Okay. Yep, it's working.
It is nice.
Yeah. So now it's working, and it's with a 150. It's already modifying the EIP.
150.
Yep.
Yeah.
And it's all A's as we want it. All right. So now the next step is to create.
Yeah, we have to find the offset.
To find the offset, yes. And then for that, we're gonna use your thing here. Okay. So to verify, to create the pattern.
Yeah, that's a Metasploit Ruby script that we can use. So basically what we're going to do is send a unique, so right now what's happening is we're sending A's, so we don't know where it's just a bunch of A's. So what we're going to do is we're going to use pattern create to create unique characters. We're going to send that instead, and we're going to find out, it's going to help us find out where the EIP is being overwritten, if that makes sense.
Yeah. I know there is a quick command that we can use.
To do what?
To do the pattern create. There is I mean, I know the.
Abdul, do you think that if we use Metasploit's pattern create, they'll count that as the one Metasploit usage on the exam?
That's actually a good. Well, here's the thing. Technically, we're not like logging into Metasploit and actually using the built-in modules. What's happening is Metasploit has that within it, but you can actually just download that one individually. Let me show you where it is. I have the script for it right now. 1 second.
Okay.
Yeah. So what I do is I do locate pattern create or pattern, create, and then you can use it from there.
Yeah. So Chris, this if in my own opinion, but then again, I don't know what the practice are going to say. We're just using an external script. There's nothing different from this or just downloading some script from GitHub. But like if we were logging in and using the actual Metasploit framework, I think that's what they mean by it.
Okay. All right. Cool.
My Ruby's not working.
So now we gotta do.
So now we have to run the pattern create and then specify the size of the buffer that we want.
Yeah, and it's going to give us a number of Yeah, that's exactly what we have to do. I'm just looking at my notes now.
Yeah.
No.
All right, so my Ruby's failing.
I'm getting that same error, Jesus.
Yeah. There must be a pattern creator in Python. I'm gonna use this one. All right, so I'm gonna use this one that I sent you guys.
Okay.
So it's so simple that in reality you don't need to do something very advanced to get there. What it does is basically create a pattern that you can then.
Okay. So basically, all it's giving you is a number of different, just unique characters that you can then send to the actual application to see where in memory the EIP is being overwritten.
Correct.
Okay. So all you're doing in the script here is adding pattern, and then you're going to send the pattern instead?
Yep. So all I'm doing is, instead of adding the buffer like this, I'm going to comment this line, and I'm going to make my buffer equal to the pattern.
Yeah.
And then what's interesting here is that because it's Python, we could even add that to the script. So we could even, load or execute this pattern creation into a Python script.
Okay.
So something interesting for another time. All right, so let's do this, and then let's exploit it. Oh, let me double check something. My buffer is equal to pattern, and then okay. So all I need is to restart this. And
Jesus, can you paste that script in the channel?
which script?
The one that you just used. I was using the old one, the first one that you had sent.
Okay. This one, the exploit, you mean?
Yeah, that one.
Oh, that.
Thank you.
What's that? Let me turn on the heat. It's fucking cold. It's 65 in here. Okay. All right. So restarting this thing here. Okay, touch this thing. I think it's useful to have like a local Windows 7 32 for OSCP exam, because you might want to debug something locally.
Yeah, I think they give you one.
Yeah, but what I think it's, it's also good to have something that you can test
on your own.
Yeah, I don't know, maybe. Okay. And then I'm taking this value right here. And I'm looking for it now. Oh. What? Mm. Okay, and the power is not offset. Okay. So it's 0x. All right, so it says here 146. All right, so that's the offset. So what that means is that I can do my buffer equal to.
Jesus.
Uh-huh.
When you did the so when you got the value, did you need to convert it or something?
No, you do it like this. You do you type it like this.
Oh, you have to put 0x at the beginning?
Yeah,
Okay.
yeah, 0x.
Okay. Okay, yeah, and I got 146 too. So, you know, what's interesting is you don't have to have the same number of like, so I was using increments of 5 instead. And for me, it was saying that the application was crashing at 201 bytes. So it doesn't really matter, as long as you can crash the application, it doesn't matter what the number of increments you use are.
Yeah.
All right, so 146.
I guess there are 6. Let's see. 1, 2, 3, 4. Okay, 4. All right, so what I'm doing here is sending then 146 A's, then sending 4 B's, and then sending the rest of C's. That's going to be my new buffer.
Okay, that makes sense.
And I'm going to test this right now. And then I should have all B's in the EIP. So it gave me an error with string and in objects. Okay, so basically didn't like that. Okay, 4, okay, wait, this is by 4. Boom. There you go. Or not. Okay. Or not. All right, there you go. It worked. Okay, so now we got EIP control. So,
Jesus, can you copy and paste that script you just ran
yeah,
in the Slack thing?
sure. Say, guys, I'm gonna go get a sweater. Be right back.
No problem.
Are you guys football fans at all?
What'd you say?
You guys football fans at all?
I'm more of an MMA fan.
Oh, nice. Yeah, if we're still going around like 12-ish, I'll probably have to bounce for the Patriots game.
All right, no worries.
Yeah, I'm definitely going to rewatch this video that we're recording just so I get a better sense to prepare for the exam, because it's definitely a lot to just to, you know, move step by step.
Yeah, I completely agree. So I don't know if it's helpful at all, but like I put like a quick little checklist in there of what you need to be keeping an eye out for when you're trying.
I saw that, yeah.
Yeah, so it just helps me kind of keep track of what I need to do and where I am in terms of what I'm trying, what like the actual exploitation.
Nice.
All right. Where you guys at?
Jesus.
Uh-huh.
Question. So that script that you pasted in the Slack, the latest one that you just pasted, how did you determine what the number? So you see how you put my buffer equals A times 146, which is the offset value, plus B times 4, and then plus the C. Why did you add the C?
So the C's are just extras that I want to have after B, just to make sure that the 4 bytes that I'm sending here are actually in the right spot. And you know, if I see a C, right, in the EIP, then it means that something's wrong. You know what I'm saying?
Oh, okay, I got you now. So basically, you're just adding. So I think basically it's just because the total number of bytes that we were sending originally has to match here, right?
No, it doesn't really matter. The reason why I send C's is just to make sure that I don't want to have any C in the EIP. You know what I'm saying?
Okay.
It can change this number to be 200, 500. It doesn't matter because, as you said, you can send more than the total amount of bytes that you send.
Mm-hmm.
What matters is that it's larger
Oh,
than,
okay, okay. I get what you're saying now. That makes sense.
right? So
Yeah.
I'm just using 200 here, but it can be less. So what's interesting is that sometimes you need a shell that will enter in the C area rather than the A area.
Mm-hmm.
So you notice that for the A area, we only have 146 bytes,
Mm-hmm.
and then that will be probably a very small shell. So if we want a bigger shell, we might need to add it into the C area,
Yeah.
right? So then we can test here, like trying like 1,000 bytes in C and see if those if those bytes will actually stay in memory.
Okay. That makes sense.
All right, so I'm gonna um, actually I'm gonna change this code a little bit and call it offset because I already have the number here. All right, so the next step then is to, we already have this. The next step will be to identify
The bad characters.
the bad characters. So let's see, and the guy that you sent. All right, so pattern create. Right, essentially turn of A, pattern create, verify offset, and then check bad characters. Okay, so for the bad characters, we just need this and see if any of those characters stop and they're not there. It seems like you modify this or something. So why do you have it like this? Oh yeah, I got it. Okay, so for that we go to the exploit, and then we first try bad characters. All right, so I'm just putting this in a nice format. Um, this should work. You know what? I think let me double check how this thing does here. Oh, yeah. All right. Is this the last one? Active one. Oh yeah. So how was it again? You have to put the back characters in the C's. So we can do then my buffer will be like 16. All right. And I'm gonna do math charts. All right, so I'm gonna try to exploit it again, looking for the bad characters. Make sure this is running. Right, then boom. Right, it runs 42, and then we need to look for the C's. Okay, so this is the tricky section. B address relative. Okay, so the address is 501A94. Come to string. So I jump here, find rep, go to expression. No. So where is this in the code? All right. How was this? This is the memory. Okay. BBB. Okay. Okay, let me remember this. There's memory down for example. Abdul, do you know how to jump to the space where we have the code here?
The bad characters.
Yeah.
I think I wrote it down. 1 second. Let me check my notes again.
So because I see them, this section right here, I think it's the memory, the stack right here.
Yeah. So where the bad characters would show up would be in the bottom left corner. So that's
Here,
where we
no?
would be looking for the bad characters. So we need to find out where the EIP starts because we're sending it after the EIP, which is the 4Bs. So we need to find out where the 4Bs are first.
All right. So we're gonna
So
do
so
that.
if you check this out. If you look, yeah, you got it. Do you see where the 4Bs show up?
No, not yet.
So in the bottom right corner, you see you see the line,
Yeah.
that one. So that's the address, that's the memory address location. So just do the same thing you were doing, but type in that location to find it in here.
Right.
Yeah, you can try that, and then type in that memory location. See if that shows anything.
But here it's not about, okay. Find reference, search for breakpoint, go to expression, to expression to follow, no. Find reference, search for breakpoint, memory on access, memory right. Let's try search for binary string. Hex is 242, 42. No, 41. Oh no, it will be 42. 42, 42, 42, 42. Not found. Not found.
Yeah, Jesus, you can just do that. You didn't see it. So
No.
so right click in that same box where you are.
Mm-hmm.
Go to search for, I think. Which one did I just do?
Uh-huh.
Hold on, let me make sure I did it right just now. All I did was search for, nope, sorry, wrong one. Hold on. I just need to remember which one I did. Yeah, so you do go to, right click, go to,
Mm-hmm.
and then expression.
Why I got. Oh, what is it? Okay, go to expression.
And then type in that memory location. 00501A90. Yep, and if you check right there at the very first line, you see the 4Bs.
Yeah, yeah.
So now we just need to change the viewing format so we can actually understand what it's saying. So that's what I'm trying to remember how to do now. If we go to, let's see.
No, I think you have it right here, right? Because these are
these are the 4Bs, but everything after it is the bad characters, and we need to change this to a format that we can actually understand. But
well,
there's an option. You see it?
Yeah, because these are the X numbers, right? So 0, 1, 0, 2, 0, 3, 0, 4, 5, 6. So that's the same thing.
Oh, yeah, you're right, my bad.
Yeah, so that's what you have in your exploit, right?
Yeah.
So then failing 0, 4, 0, 5, 0, 6, 0, 7, 0, 8, 0, 9, 10. It's failing.
So I'm checking that now. 1, 2, 3, 4, 5, 6, 7, 8, 9.
It will be 0A. It's not there.
Yeah, so 0A is one bad character. Okay,
yep.
Wait, where was 0A again?
Here, you see, and so when we're analyzing the binary here, and then after these are the Bs, and then here these are all the bad characters that we're sending. So basically, those are the X numbers that we're sending here: 0, 1, 0, 2.
Yep.
So what we'll have to do is basically see which one is not showing as we're sending it. So 0A, it's what goes after 09, and it's not showing. It's just showing 00. And then there was 0B,
Oh,
C, D, E, F.
I see.
10, 11, 12, 13, 14, 15, 16, 17, 18. The other one, it's, I don't know if it's 00. We get 08, it's 1. So, okay. Then 00 is not, then 10, 11, 12, 13, 14, 15.
I think that was the only bad character, right? I'm not seeing any more.
Yeah. Yep, I think that's it.
Yeah, everything down to FF is good. So that was so the 0A is the only bad character that we have in there.
But we should also include 0x0.
00, yeah.
All right, so that's good. Then how do you create a multi-line comment in Python? Multi-line comments in Python. Got it. Okay. All right, so those are then the back characters, and then what else? What else? What else? Next step is to.
So now we have to generate our shell code and then exclude the bad characters. I think that's the part that we have to do.
Yeah, so another thing that we didn't do this time, but sometimes you need to try this again with you need to modify the exploit, remove the bad characters that you're sending, and send it again.
Mm-hmm.
Because sometimes the bad characters are kind of like cutting the rest of the bad characters. So it's like you send, let's say, like we have a 0A, and then after the 0A, everything gets blank, right? So basically, this character is affecting the rest. So you need to make sure that you change it, and then you keep seeing what happens, right, with the rest.
Mm-hmm.
That wasn't the case in this time, but something.
Oh, okay, I see what you mean.
Okay. Let's.
Wait, actually, I think the next one is we got to find the jump ESP instruction.
Yep, jump ESP instruction. So that one's tricky. All right, that one's tricky because it depends on the operating system where you are.
Mm-hmm.
Well, let me remember here. All right, so basically, in the OSCP guy says that we should use Mona.
Yeah, mono modules.
So the way to do it is just type here Mona modules. And then Mona will tell you, all right, so looking for one that doesn't have that, it's false on all this stuff, safe.
Mm-hmm.
EH. So there's nothing with a lot of faults, just this one, right?
Yeah.
That's our vulnerable application, right?
That's the application itself, but am I seeing something wrong with it? So identify. Right. All right, so basically what the OSCP guy said is to look for a jump ESP code, and then if you don't know what is the jump ESP code, you can locate NASM shell and then try that one. Probably it's gonna fail. NASM jump ESP. Let's see if this works. I have something wrong with my Ruby that's not working. Let's see if there is a Python version of NASM. Python. Okay, so we have a couple of options. One is this, if it's failing for you too. I'm gonna try that one first. All right. And then I'm gonna try the jump ESP. So the jump ESP there is FFE4. That's the instruction that represents the jump ESP, and that's what we're supposed to search here. Now, few interesting things. Like, we don't really need to know this. Like, we can just put it in our notes and say, you know, this is one of the instructions. But what's interesting is that in some cases, we don't find a jump ESP, and then we need to find something else. You know what I'm saying? So it would be wise to have a couple of other options or other instructions, not only this one.
Okay.
You know what I'm saying? There might be other instructions that you can use to jump. And then the other point is, I'm not sure if there's any other DLL or anything that we can use.
I think that's the only one that suits the criteria, that one right there.
Yeah, right. And this is the actual exe file. Okay. So then here, what we need to do next is basically just search using Mona again. So it will be Mona find S, and then we're gonna find, we're gonna look for the XFF XE4, which is basically, you know, with this instruction right here, FF and E4. And we're basically looking for a jump, and we're gonna do it in the module called, in this case, it's this one, which is, let me see, it will be SLM. I think I'm missing something. I'm missing a step, I think. And, let's see. So the module name will be just,
I think it's just the executable, because in the OSCP guide, it talks to the SLMFC DLL, but I think that's just because that application is a DLL versus.
Yeah, you're right. So I tried with a name, and then I got 2 results. So it says here that we could use these 2 addresses. Let's see, it says here, total pointers found. All right. Okay, got it. So so we have 2 here, and then we need to use one that doesn't have any back characters, but in theory, both of them will work. So then I have here, okay, so we can follow in this assembler to see where that goes to. There you go. This will be an address that we can use. 080. All right, let me double check here. Yes, so okay, so 080414C3, it's one of the options in that I have. So I'm just gonna go here and type it in my exploit. Where am I? Just go back here. And then, all right, so what's tricky here is that we need to do it on the reverse order. So it has to be something like, let me first type the address that I can use.
Because that Indian format?
Yeah. So I need to.
I'm reading about it now.
Yeah. So I'm gonna move this here and type it. It's 080414C3. Right. That's the address, and then that means, well, this is one of the addresses, and the other one was. I'm gonna go back here and say Right. What are you? The other one is this one. And then that will be 080416 BF. So we can use both, and then we have to do it in reverse. So it will be C3 14 04 08. So it's in reverse, but at the same time, like not exactly like not 3C, but C3 14 04 C8. Double check. Yeah, 5F. All right. All right. So that's the address for the EIP. So let's just call it here EIP. And then say and then here. So what we're gonna do now is we're gonna change the B's for we're gonna change the B's for the EIP. Right?
Mm-hmm.
And that's it. All right, let's try that. And what else? We also want to see if there is we need to create a breakpoint. I'm using this one for December. What is the breakpoint? Toggle breakpoint. Look like we're trying to set it. The breakpoint in the middle of some commander data.
Are you trying to figure out how to add the breakpoint?
No, it's just that it gave me an error when I was gonna do it. So let's double check that. All right, so this is the address. This is this is a suspicious breakpoint that he gave me, so I don't know. Just gonna keep with it. And then I think I need to restart this. Oh no. I think it's ready to be executed. All right, then let's exploit this. So let's just plug it in. Let's see what happened here. Yep. So I think I got it right.
Yeah, it looks like you got the correct value of the EIP overwritten there.
Yep. And then it got there, and now I have yeah. So it got overwritten there, and then it's jumped to the ESP value.
Mm-hmm.
And then what I have in the ESP, it's 41. Sorry, this value right here, which are the C's. So what's next? I need to jump ESP, breakpoint at blah, blah, blah. That's good. All right, so if we jump into this with F7, F7, it jumps into the C area. Nice. It's interesting that he jumps right into the C area. Cool.
What do you mean this? Oh, okay, the C is, and I guess the C is where we're gonna place our shellcode then.
Correct.
Okay.
So now all we had to do is, I'm gonna restart this thing. And then while that's restarting, we have to create our shellcode. So MSF Venom. Let's use Windows shell reverse TCP. Localhost equal, I don't know where my localhost is, but let's just investigate it really quick. Okay, and then it's my localhost. And then local port, let's do
Hey guys, I gotta run, but it looks like you're in the finish line right now.
Yeah, I'll post a video of this when we finish.
Awesome. Yeah, and I'm gonna rewatch it also, and just to make sure I basically understand each step.
Cool. Yeah, we're going slow, but because we're kind of learning at the same time. But but you might want to speed up the video and when you're watching. So. All right. So what's cool?
But I mean,
that we're not using the same exercise that we have in the OSCP guide. So that means that you have like.
But we're kind of using it as like a guide, though.
Yeah, we're using it as a guide, exactly. All right. Cool. See you around, man.
All right. Cool. See you guys.
Take care.
All right. And then we have to specify the back characters here. So let's do encoding also. That's 86. C data 9. And then the binary, let's avoid these two. Right? Let's do output to shell.raw.c. Okay. Now it seems like you got an error. Let's see, she got invalid format selected, format. Oh, yeah, and type. C. All right, so the commands here were, filling my notes 1 sec before I move on. Basically using Mona first. Use Mona. Modules.
I'll be right back, Jesus.
Okay.
Hey, I'm back.
Cool.
So you were able to successfully overwrite the EIP with the location in memory, right?
Yeah.
So I'm testing that out, and for some reason, I don't know what's broken, but all of a sudden, the application is no longer responding to anything that I'm sending to it. I don't know what's wrong.
It's not responding to anything.
No, I restarted it, so maybe I'm just doing something weird. I'm checking now to see.
Yeah. It's yeah, that's weird.
Well, never mind. I got it.
I got it.
080414 C3. Okay.
Right. So shellcode. I guess this is it. And
Flash B for that characters. Jesus, did you get it to work?
Yep.
So after you find the ESP and you generate the shellcode, where in the script did you paste the shellcode portion? I just did it now, but I'm not getting anything back. I'm wondering where I messed up.
Yeah, so this is how it goes. Let me see. Oh yeah, it's good point. So this is how you do it. You have to you copy your shellcode, right?
Mm-hmm.
And then in the buffer,
Mm-hmm.
you need some knobs.
Oh yeah, I forgot to add the knobs. How many knobs did you add? 8?
8, yeah. But I did it also without the knobs. It failed. It didn't work.
Oh, so you have to have the knobs. Okay.
Yeah. Just I needed to double check that it was actually needed, and it is.
Okay, that makes sense. And what made you decide on adding 8 knobs specifically?
I'm just following the guide on
Oh, okay.
OCP. They do it with 8.
Okay, gotcha. So knobs times 8. Okay. Nine zero. All right, let me test this out again. Smudge is still failing. So all you did was my buffer equals A times. So the offset plus EIP, what is that exactly?
So offset is this value, 146,
Mm-hmm.
and EIP is the address.
Is the address that we added in memory, right?
Mm-hmm. The address that we detected that is the jump to ESP function.
Mm-hmm. All right, I'm just testing something out now because that's correct. X. Let's see, shellcode. Oh, I think I know why I fucked up. The only bad character was 0A, right?
Mm-hmm.
All right, well, I'm making some type of progress at least now.
What's happening?
So I got the shell back. I can see myself. I can see a communication on there, but I can't actually execute any
Type ls, type something.
Yeah, I am, but nothing is happening. So I think I need to change the actual payload that I'm using. Let me try changing it to Windows Shell. Where's TCP? And when you add the exit function equals thread, it doesn't crash the application when you quit it.
Yeah.
Which is pretty cool.
All right. So
I'm still working on mine. I'm not getting anything still.
got it.
Dash LVMP 4444. Platform Windows. What payload did you actually? Let's see, what am I doing wrong here? Windows shell reverse TCP.
I'm using this exploit.
Okay, let me take a look.
That shell code.
Windows shell reverse TCP lhost exit from thread. F. Oh, I know why I'm doing something stupid again. All right.
All right. So what else? What else is here?
Wait, what the heck just happened?
What's up?
The application DoBufferOverflowGood.exe,
Mm-hmm.
it just disappeared. I don't know where it went. I was running it and it just disappeared.
Do you have an antivirus or something that's?
No, I don't have anything like that running on here. All right, I'm just gonna re-download it. This is stupid.
Right. So there is another similar project that we can do.
Mhm.
It's called Bone Server that has multiple vulnerabilities for
Mhm.
buffer overflow too.
Okay.
So I'm just gonna download it here.
Okay, I finally got mine to work.
It worked?
Yeah, it worked finally.
Nice.
So, Jesus, do you want to try the hack the box box that has the actual buffer overflow vulnerability?
Which one is it?
It's Chatterbox.
Okay.
It should be pretty easy, honestly, but it's just like a live way to see how this would work somewhere in the wild.
All right, let's try that.
Let me make sure it's still here, though. It's one of the retired machines. Yeah, it's still there. Chatterbox. 10.10.10.74.
$74, you said?
Yeah, 10.10.10.74.
Got it. Chatterbox.
I definitely need to do some more practice on this buffer overflow stuff.
Yeah, it's you need to keep it fresh, you know. It's
Yeah.
not easy. You know, I like to use Mascan. Mascan. You find the open port?
Yeah, so I have my old scans from it, but for some reason I can ping it, but I can't. I don't see any open ports. Hold on, I'm trying something again.
What was the last open port that you found?
I'll copy and paste it to you now. This is stupid. For some reason, it's not showing. I don't know what's going on. CD. I'll send it to you now. The boxes, chatter box. Sorry, it's the wrong one. Hold on.
Maybe we need to reset it.
Yeah, I'm gonna try it again now. Maybe somebody broke it. I'm resetting mine now.
Me too.
Is it just me, or has Hack the Box been really slow lately?
Not sure. I haven't had any issue. Yeah, I don't find any open port on that.
Yeah, I think something is wrong with the host. I was having the exact same problem too. If we reset it and it still doesn't work, we might just want to move on to something else then, so we don't waste too much time.
Yeah, I already reset it. Don't know how much time it takes to reset, but
I think mine's just finished resetting. I'll try this again.
oh yeah, mine works now.
Okay, perfect.
9256.
All right, for some reason mine isn't still isn't working, but so you found the two open ports, right?
Yeah.
Okay.
So when I try to see what is in there, 9255,
Mm-hmm.
it's web. It says that it accepts get head post options.
Mm-hmm.
So I'm doing Nixo.
So to save a little bit of time, if you do some quick research on HChat, you'll find something interesting.
Oh, okay. Let's see. There's a remote buffer overflow.
Yep.
Or
Perfect.
HChat.
What the hell? Why isn't this working? This doesn't make any sense.
It's interesting that the exploit that I found, it's working on UDP in UDP.
Mm-hmm. Is it the one from XWorkDB?
Yeah.
Yeah, that one should work. Let's see. Did you get it to work?
Not yet.
So you actually have to replace the buffer in there with your own shellcode, and you can just generate it with MSF Venom.
Yeah, that's what I'm going on.
Oh, okay.
You did that already?
Yeah, I did it already.
Yeah, the difference here is that we are not actually finding the.
Yeah, we're not actually doing the buffer overflow export. We're just using it to get a shell onto the box. Okay. But I mean, most of the time, that's probably what we're going to be running into, right? In a while, at least.
Yeah, but if it's practice for
OSCP, naturally, yeah, that's not gonna. Yeah, that makes sense.
yeah practice for SCP, you have to actually do it. So the OS, I don't know what the OS is, but
It's Windows.
okay, hopefully. I got in.
Yeah, this one wasn't too hard at all, honestly. It was just one of the only boxes that I've seen on Hack the Box that actually uses a buffer overflow exploit to get in.
Yeah. And then what's the privilege escalation that you used?
I don't remember exactly what I used, but I don't remember. I was looking for it in my notes, but I guess I didn't write it down. It was a long time ago. Let me see if maybe I can find it.
Well, let's see what we have here.
Oh, I know. I remember which one it is. Have you ever used ICACLS in Windows?
I don't think so.
So it's the equivalent of like chmod in Windows. You know how you can change.
Yeah. I've used ICACLS. Yes.
Exactly. So you can do that on the administrator folder and gain access to that folder.
Okay, so let me see what I have here about that. Yeah, but my question is gonna be then, how do you get to know that you can do that?
So I just did a lot of enumeration. I was Googling a bunch of stuff to see what I could change. I ran some Windows Priv Checker scripts, but I didn't find anything interesting. So I started doing some research and I found out about ICACLS, and I didn't know anything about it before. And I tried it and tested it on the administrator folder, and I was able to get access to it finally. Are you logged in as Alfred right now?
Thing. Yes.
Okay, cool. So yeah, that's what I did to find it. I just did a bunch of research to see what I could do to basically get root on the thing, and it mentioned using ICACLS.
Yeah. Okay, local service path. There is this program called Access Checker that might also help.
Oh yeah, to find out what files you can change, what you can change folder permissions on.
Yeah.
Jesus, you're gonna be online for a while, or are you heading off soon?
I need to spend some time working on something else.
Okay.
So yeah, I won't be able to do more today. Why?
Yeah, because I'm about to hop off. I don't know what time I'll be back. I gotta go take care of a few things.
All right, no problem. Yeah, I mean, I see you online. I'm gonna finish this one and then I'm gonna have some lunch and then I'm gonna be working the rest of the day. So.
All right, no problem.
All right, this was good, man. It was good practice.
Yeah, it was really good. I took some notes. I'm gonna go review this some more and maybe practice the Vuln server later.
Yeah, I think it's important to be able to do this without any notes.
Yeah, you have to know it. Yeah, you have to just repeat it over and over again until you know what you're doing. Yeah.
Exactly. That's the best approach. And then do it with different services. So you can test like different scenarios and what to do when it gets complicated, etc.
Yeah, I'm gonna test that out. Make sure I'm ready for the OSCP.
All right, miss.
All right, have a good one, users.
You too. Bye-bye.
Bye.